All right, everybody, welcome back to another Ask a Dev Unreal Engine live stream. We are continuing our Octa-bot series. Actually, we're going to finish our Octa-bot series, or at least put a bow on it. I don't think we're ever going to be done learning things about ControlRig. Off the Rails PVM, it's good to see you all again. Apologies for the little bit of a delayed start. We had some streaming software fun, as always is the case. Warren Wong, maybe? Warren, welcome to the stream. So as we get started, real quick shout out to the community. Everybody, thanks for supporting the channel, for helping spread the word. It's actually what allows us to keep going. As usual, everybody in Discord is awesome, helping each other out, just all across the board, helping with projects, ideas, questions, etc. As I'm building videos and recording, I obviously can't do it all, so I appreciate everybody's help in there. And shout out to our newest Patreon member, Nader, I think it is. Thanks for your support of the channel. Let me know if the audio sync is good, y'all. Hopefully we're good to go today. And today we're going to be taking a look at a couple little polish things. We want to fix the staccatos. I think that's the music term. The staccatoness of our foot placements. I want to actually revisit the vector math that we had talked about for calculating our final foot positions. We kind of just did a hand wave with that last time. Let's knock that out. And then also going to go ahead and do a quick summary of a bunch of the learnings that we got from this series. We're not done with ControlRig. We have many, many more things to learn in ControlRig, but let's get going. And then if we have time at the end, as always, we'll just open up for questions either about the Octa-bot or ControlRig in general. And then obviously I will take this whole package and upload it for Patreon members to grab and dissect, etc. So with that, let's go. Okay, so if you recall, as a quick recap, when we press play right now, our character is moving, our legs are working, and they do take into account the uneven ground. All right, but there's something about this version that has been bugging me, and it's the speed at which the legs are moving, and it doesn't feel great. So as a sanity check, I wanted to do a couple things. So let's escape out of this. And if we go into our rig and where we calculate our world velocity, is it? No, it's our timers. I think it's our timers. Somewhere in here, we're multiplying by a factor that changes our interp speed. You know what? I know how to find it. If we look at our cycle distance, maybe find references by name, divide that result. Here we're multiplying. So is this where we want to do this? And let me just double check one other place. Our cycle duration, divide, add, modulo. Okay, I need to figure out where we want to do this. What we need to do is we need to affect our time slightly because we want it to take longer for our foot plants to happen is basically what's happening. So let me just make sure I have this in the right place. So, okay, so let's take here our cycle distance. And what I'm going to do is I'm going to multiply this by 2. I'll multiply this by 2. So what this is going to do is this is actually going to change the duration calculation. So if we just go to, let's see what that does to our foot placements. They're slower. Okay, also they lag behind more. This feels way more natural and less staccato to me. Okay, and we can change this as we change this. If we go, we can make this extreme. And now extreme's not going to work, but let's just see what it looks like just for our own sanity. Okay. I mean, it doesn't not work. The character's a little bit more floaty, but the foot placement is kind of working, which is cool. But you can see we can kind of adjust the speed of that by changing the calculation of our cycle duration by affecting our distance time. So I'm actually going to go down and let's try 3. Let's see what 3 feels like. Does that feel pretty good? because there's one other thing that I want to play with a little bit. Feels pretty good. What do y'all think? We could always go 2.5 maybe. All right. Now there's one other thing that I want to take a look at that we talked about several weeks ago now, because we've been doing this for a while. Originally when we set this up, we had the idea of how long the foot stayed planted on the ground. And when we talked about it at the time, it was based on this graph. So depending on where this point is, like basically it's going to stay on the ground, locked to the ground for 0.2 seconds of the whole cycle. And as a result of that, I feel like our cycle is feeling a little bit floaty. So now that we've increased the length of time for it, let's just exaggerate this. Let's go all the way 0.5. And I want to make this linear. The reason I want to make this linear is because if we look at this chart, I don't want the curve to go below 0. Now, why don't I want the curve to go below 0? I don't know what below 0 would do to any of our math. Also, there's a thing in animation where when you're enabling and disabling IK, if you went above 1 or below 0, it would cause the whole system to destabilize. So it's just kind of built in that I don't want any weird tangents in here. So let's just see how that goes. All right, so now we're going 0.5, and let's see what that does to our cycle. Oh yeah, so our legs definitely stay on the ground a lot longer, and there's a lot more staccato in the air now. So this is exactly what I was hoping for, in the sense that these are the dials that we can use to affect how our, I'm going to try 0.4, with just the overall feel of the walk that we have. So if we go 2 here, usually I don't like changing 2 variables at the same time, but just for kicks, let's go ahead and do that. I think that feels way better personally. All right, but big thing is we've confirmed we do have the dials that we need to be able to adjust our walk. Now, I didn't test this. I know I'm going to regret saying this, but let's try it live. Why not? And I managed to get something in my eye. What if we change the walk speed of our character, y'all? So if we go to our third person character, what I want to know is if we take a look at our movement component and we change our walk speed. Where is it? Max walk speed of 500. Let's cut this in half. Oh, it still works, y'all. That's one of those things that could easily go really badly. Okay, so that's cool. That means we have accounted for velocity correctly. I'm going to go 0.3 on this, and I'm going to see if I can do a flat out. Let's try auto out and see if we can't flatten this so that we get a smoother out and see what that feels like. Yeah, I think that feels pretty good. Now, obviously, this walk speed doesn't feel good. It feels like we're walking through quicksand. So let's go back to, I think 500 was good for our default character, and we'll call this done. Okay. I think that feels way better than that staccato thing that we had before. Okay, so let's talk. All right, so that's that. It just feels better, kind of more representative of kind of the demo setup I had done before all this. So let's go have a quick little conversation about vectors. And what we're specifically talking about now is our foot placement. If you recall, last time, what we did is, let me get a brush in here, and let me change the size of my brush. Okay, if you recall, I'll do my best for drawings. All right, so we have our character's head. Oh, I've got some super smoothing on right now. All right, and then we have a foot. We have 8 feet actually. Let's just call this many feet. And what we were doing last time was we were picking, for this point right here, okay, we were picking a point that was 250 units above, 250 units below, and we were drawing a straight line. Like so. And the problem was, if there was a ledge here, we would get it. And towards the end, I mentioned, rather than doing a straight line above and below, what if we picked a point that was 50 units above the head, and we used the foot? And we just drew a line from here to here. However, drawing a straight line is going to be tough, so let's just do it like this. That would serve two purposes. One is if there is a wall here, okay, of course, if there's a wall here, what that does is now when our vectors or our point of impact is calculated with this line like so, we get a point that's about right here. Whereas if we were going straight up and straight down, our impact point was up here. Okay, but what we did last time is we took the unit above the head and we just used the in position. We didn't actually do the vector math because we were running out of time and sometimes vectors scare everybody. So what we actually want to do is we actually need to project past the foot. Reason being is this foot might be in the air, or it might be already off the ground or something like that. So much in the same way we calculate above and below over here, we kind of want to go past that. So how are we going to do this? What we're going to do is a little bit of just simple vector math. We're going to do it in the blueprint here in a second. Okay, if you don't recall, to get a vector, you subtract the end from the start. So this is our end point right here. This is the end. Okay, our start is going to be the head. Awesome writing, I know. Okay, and that is going to give us a vector that looks something like this. Remember, a vector is direction and magnitude, nothing else. And it's going to be of length, let's just say 100. Okay? Then what we're going to do is we're going to calculate the unit vector. And the unit vector is the exact same vector, except it's of length. All right, are we back? Hopefully you all can see me. Apologies for the little hiccup there. We had a full-on blue screen of death. So let's see if we are back in action. Okay, great. So as I was saying, what we're going to do is we're going to calculate the unit vector. And then we're going to use that to draw a line that goes past the end of the foot. All right. So let me show you how we're going to do that. Hopefully that drawing was enough, because I'm not going to launch so many applications this time around simply because that was fun. So let's get Unreal back open again. And we're even only going to launch one Unreal. Let's see here. This is the Octa-bot series. I hope I don't need a new computer, you all. Okay, Unreal's launching now. Let's see if we can restore that. Could not restore it. Of course not. Okay, so here's a question for you all. It looks like the video is a little bit splotchy right now. Does it look okay, or is it blurry for you all? Let's bring back our tutorial live control rig. Okay, great. All right, so here we are. We're back in here. Let's find where we were doing this. All right, so basically everything we just talked about, we need to implement in our blueprint. So let's go to our foot lock positions, updating our foot targets. And this is where we kind of left things dangling last time. We were just like, we just did a little bit of hand wavy stuff. This is where we're getting the head. And from the head position, okay, we were adding 50 units. So this is getting a point above the head. That works. That is our start for our sphere trace. But look at where our end is. Our end right now is just where the foot is. It's not doing any calculation to overshoot if it needs to. All right, and we had started to talk about what that might look like, and then that's where I was like, oh, vector math. The maths don't like us. No, not going to do it. Okay, but we're actually going to do the work this time, just so that we can put a nice bow on this. All right, so remember what I said. We have to calculate the vector from where we are, which is here, the end of the foot. This is this piece. This is where we want it to be. So let's get this, subtract. Okay, and we're going to subtract the end from the beginning. And the beginning, in this case, we want to make sure we're doing everything in world space. So let's go subtract the world foot. All right, so this basically, this here is now a vector. This was our old way. Remember, this was 250 units straight above, 200, or it should be 250 units straight below too, but you get the idea. So that's what we were doing before. All right, so now we've subtracted, we have that information. So now we have a vector that goes from the head to the foot. Now, we could not do the whole unit vector and not do the whole addition, and we could just scale that. You know what? That might be easier actually. So what we could do is we could just scale the vector that goes from the head to the foot by 20%. That's one way to do it. And then the cool thing about that is we don't have to, I'm making this up on the fly, y'all. Roll with me here. Then what's cool about that is then we don't have to calculate the unit vector. And so let's just go through this. If we were to do it the original way we talked about, we're going to take this, we're going to get the unit of this. All right. Then we're going to take this unit and we need to multiply it by some distance. The distance being, let's call it scale. Remember, because in control rig's world, it's scaling. So we're going to scale that vector. Let's say, so right now the unit vector is 1 unit long. So what we're going to do is, let's say we wanted to go 50 units past the foot, because that's how far we want foot detection to work. So let's go 50. All right. And then remember, a vector is only a magnitude and a direction. It is not a location. So then we would have to add this back to our original where we were with our foot. And then this would give us a not accumulated add. I don't know what that add was. I want just a simple add. Okay, so then we're going to take this now scaled vector, add this in here, and this becomes our endpoint. That's kind of wild. One, let's just see if it works, because, you know, vector math is always fun. Okay, so our feet are kind of working. Yeah, they're still working. All right, this is sort of the test though. Why is it still going up? I don't know why it's still going up. So our sphere trace is going, so this is where what we want to do is we want to draw a line. And we're going to draw a line. This is our debug line here. We're going to draw a line from whatever we're feeding into the start, which looks like this 50 units from the head. That's cool. And then we're going to put in our end. That's this. Let's see what this is doing. All right, let's compile and save this for a second. And then let's go back to our map and let's press play. And then I need to bring up our debug commands. We're going to do 2 debug commands. Nope, that wasn't it. Okay. Oh, I remember why. Okay, so when we're moving, that line is working. You can see it. Okay. However, that was part of the problem that we ran into last time. We need this calculation to happen even when we're idle. So when we're idle, it's using something else. but the actual math is working. Now, let's do this. Let's solve this two ways though. So first, if we escape out of this, all right, we don't need all of this. This is a lot of extra subtractions, units, etc. If we just get the vector from the head to the foot, this guy here, and we multiply it by a factor, then we don't have to, we could save ourselves the unit. We would still have to do the scale of 1.1, etc. So yeah, let's get rid of the unit. Let's scale this by 1.1. Let's test our theory. We'll go 1.1. Let's make it 1.1 for 10% longer. We'll do the add, but we're not going to add to the foot. We're going to add it to the head. We're going to add it to the head. Oh, look, we also messed this up. We need to get, oh, okay, we got a couple issues here. Okay, sphere trace from world. This is to world. We're doing the add. Here's our to world. We're doing our subtract. We're doing our scale. We're adding the two together. We need to go from world here. From world. And this needs to feed into here. And then this needs to feed into here. So we're drawing the right lines because we need to be in the right space. Or not. Let's see here. We have our head position from world. Subtract. We're going to scale that by 1.1 and we're going to, oh wait, what am I doing here? Adding it to this. I missed that. Remember, because we're scaling it by the, we're scaling from the head. So we're going to add that to this. These are both in world space. We're going to go from world for both of these, from world for both of these. Let's try that again. What in the world is happening, y'all? Mohammed, Flybird, welcome to the stream. Where things seem to go sideways whenever we try to go off track, which is alright. Alright, so let's this is to world. The trace is not my concern. My concern, and we may have a, it's possible we have a herring too here. This is 50 units above the head. We're drawing. That's fine. We're getting the target position. We're taking that. Get accumulated time, foot position, etc. This is our foot position from world. We're subtracting. Oh wait, why are we going from world here? I don't want from world. I want to. It's already in worlds. Ah, that's why. This was confusing. Okay, we had this from world here because we were plugging it straight into our sphere trace. So let's see if that's it. Okay, closer. Still not there, but closer. Okay, so we have, we're subtracting that off. We're scaling this vector and we're adding it back to the head. Okay, let's reconnect this back in. So we're going to take the foot minus the head. We're going to do scale that, add that. Let's try that. What am I missing, y'all? We are drawing to world. Okay, let's just draw the basics. So we have our head point. We know that's good. We have our foot point. Let's just draw our foot point right now. Let's just see if we go from world on our foot and we draw it, is it correct? Yes, that looks good. Okay, so we should be subtracting the foot minus the head. That should give us a vector. It goes from the head to the foot. So this, I didn't know I was going to have to review vector math here. This subtraction gives me a vector. All right, that vector plus the original should also give me Hold on, that's not right. Yeah, no, that should be right. So this should also draw correctly. It does not. What the world? Subtraction, oh, because we need to do from world. When your debug stuff is also wrong. All right, so this should still draw the foot. It does not, so that's not correct then. What are we doing wrong here, y'all? We have our head. We have a line from. That is a vector. The foot minus. Oh, we're definitely not getting the 50 units. That's part of it. We keep forgetting this because we want to go from the same place. All right, so this is in world space. So when we do our subtraction, we want to subtract the point that's 50 units above the head. That's part of it. Okay, so that's one piece of it. So now, so we basically have our line. We know that's cool. Then we're adding it back to where it came from, and then let's plug that back in. Okay. Now, the only problem is this looks correct, but it's inverted. So I think we're doing our math backwards. So let's just flip these. Okay. Now, if you'll notice, part of the problem is our scale. Like, these are at least in the right direction, but they're still not right. This doesn't add up to me. I don't trust it. Okay. So first things first. We have our head. This is our head. Okay? Going to get its world space position. We're going to add 50 units to it. So this is a point that is 50 units above the head, and we're going to draw this as the start of a line. That works. We know it's always in the right place. All right. Now, what we want is we have our foot. If we go straight from where our foot is supposed to go and we draw that line, it draws correctly. That is the vector that we want. Crash? Oh no. Whew. Thought it was going to crash. Computer is struggling today. All right, so we know that this line is valid. So this line, forgetting the rest of this, if we're just working with our debug drawing, if we take this, the endpoint, and we subtract the start point, that gives us a vector. Okay? That vector plus the start point should be the same thing. That should be a vector. This vector should start and end in the same way. So hold on a second. So this should be, I think this should be our endpoint. There's something I'm missing here. No way, dude. No way. Oh, from world. From world to rig space. It does, dude. My vector math works. It walks, yeah. We're trying to get the projection of the feet. Sunfairly, we're trying to get the projection of the feet to work against walls. Okay, so this totally works. We're drawing the right line here. Okay, we know that this vector is correct. This from this add. So let's clean this up a little bit. We have our subtraction. Now that we know that this is the right value, we're adding to it. We're going to scale this by 10%. Okay, we're not going to do an add. We don't need to. We are going to do our from world because we've already done that. And then that's going to go to our end, and this should also be the same thing to draw the endpoint of this. We can get rid of this and clean this up. We don't need this add. We don't need this subtract. Okay. Compile, save, and play. What in the world? look at where we're doing the scaling. We need to do the scaling over here. This is where we need to do the scaling. So let's scale it here and do this. And then, wait, no, that shouldn't be it either. But I guess it is. Okay, do you see how this is going through the floor now? Okay, so if we scale this by 1.5, we should see it going further through the floor. See how much further through the floor it's going? Okay, that gives us the overshoot. Man, vectors is fun. All right, so that's calculating where the start and end is correctly now, and we're drawing the same thing. It's really important when we're debugging this stuff because of this whole from world to world and the fact that sphere traces and draw debugs work in rig space. You can easily draw what you think is the debug and it's the wrong thing. It's a red herring. You're misleading yourself. All right, so compile and save. And theoretically, when we approach walls and stuff, we're better. So when we're approaching a wall, let me turn off the debug real quick. When we approach walls, as we're walking, it's accounting for that angle. So that when we're walking along the wall, you can see the difference here. As we're walking, the legs plant on the wall. But if we stop, they shoot up to the top. The reason they're shooting up to the top is because we have no velocity. So we're taking a different path through here if we have no velocity. We just got to figure out, oh, all it is all this stuff that we were doing, we're not doing out here. So we're, oh, come on. Crash. All right, that's why we save often. We're almost there. Sun Fairly, yes, we try to do live every week. Next week, actually, while we're waiting for this to come back, next week, we're actually going to do something a little bit different next week. Next week, we're going to start off our quadruped control rig series, which may or may not be control rig. Yeah, it's going to be control rig, but we're going to start it off. The first session is actually going to be more of a lecture about quadruped legs, the challenges of working with quadrupeds from multi different discipline standpoints, and some of the reasons why we often delay doing quadrupeds as long as possible. And then we're going to be, so the first one's going to be like everything about quadruped legs, or at least a cursory understanding of everything you need to know before we start our quadruped leg venture. Second class, we're going to take a look at what's available in Unreal Engine for us to use for quadruped legs, and hopefully, fingers crossed, it is enough and we don't have to build our own. But if it's not enough, we're going to be building our own quadruped legs in the videos that follow that video. So let's take a look here. Update our footlock positions. This is where we're updating our foot targets. Here, updating our foot target. There's got to be world velocity magnitude greater than or equal to 0. It does all this. Let's see here. So back to what we were doing. Sphere trace by. I'm going to search for this. I want to see where else we're doing sphere traces, you all. We got two. Idle reset. That's the other one. So our idle reset is doing the old way. This here. In order to make it work when the character is in idle as well, what we need to do is we need to take all of this. So we're going to take our foot, bones, etc. We'll do from world. Let's bring the draw line too, just so we can see it working. We're going to take the output of our adds, subtracts, scales, adds, from worlds. I think that's what we need. Okay, and what we're going to do is we're going to paste this down here and try to connect this all in. Okay, so here's our head, and remember, our head subtracts off this foot position right here. So this is our first subtract, Then we scale it. Okay, and the line, this time we're going to draw, let's draw a different color so we can see this working. Let's go with a nice blue. And I'm going to control drag this just so I don't have to chase it. Okay. All right, so now our line should be cool. And then our endpoint, rather than being this point, we got two things we've got to do. Our head plus 50, we got to go into our from world here instead of our 250. And you can kind of see it drawing here already, which is kind of cool. And then our endpoint is going to be this one, from world. We already have from world. Okay, so you can kind of see where that's going to. Now there is a problem though. Maybe, let's see. Oh, you know what? If we bring back our debug. Oh, I had escape. We're all set up. By the way, this is working, y'all. Just the fact that the legs aren't freaking out already is kind of shows that we got it. Okay, so this is how we know we are calculating this foot position during the idle, because we drew blue debug lines, and when we're moving, we get the purple ones, or the cyan, whatever color that is. So that was how I quickly kind of figured out. Now, it's worth pointing out, like with all things in efficiency, maybe all this vector, and I know this looks like a spaghetti mess, and you're all like, oh my goodness, what is, dude, this is why we went over this stuff beforehand, why I drew the drawings to explain to you the vector math that was happening. The only change that I made is, rather than calculating the unit vector, right, we walked through that, rather than calculating the unit vector and then remultiplying it, we get rid of the whole unit vector calculation. We just scale it up by 10 or 20% or whatever, far enough that the feet go through, or the debug lines go through the ground, and then we can get our detection. So a couple different things about that. Now, with those fixes, I feel like this Octa-bot is working much better now. I'm going to pack this all up, and I'm going to drop this in for Patreon members so they can download this project, dissect it, etc. I may actually put the other one in, my original one in, just for kicks. But we kind of went through a couple things. I feel like this is a much better place to put a bow on where we are. Before I open up for general Unreal questions, because we have a little bit of time left, let's take a quick second to recap some of the things about everything that went on in this whole Octa-bot series. All right, so this was a rigging challenge. All right, there's a lot of oh, actually I've got the wrong notes up here in front of me. That's a different lecture, you all. Okay, so big takeaways from this series: the logic flow and the time of using ControlRig to create runtime animation solutions. It's totally possible and it's fun. And what I mean specifically with time is everything we did to create the timers, to create the reset idles, and keeping track of the elapsed time using the delta time, etc., and using that to drive. It's kind of like a cool piece of like the runtime ControlRig stuff. The second thing that I was a huge fan of during this is our increased use of interp nodes. We used all kinds of interp nodes. We used the linear interp, we used the spring interps, there's rotation interp, there's so many different interps. So the idea that you have an object, you have an object where it was, where it's going to be, and being able to interpolate between them, using that to ease the speed at which an object travels between time and space in a ControlRig world is really cool. So I like that a lot. Let's see here. Data management is a big one to talk about. So if you recall, way back in one of our first videos, there are many different ways to keep track of all of the data that's associated with this stuff. And I think we learned a bunch of cool stuff along the way. So the metadata method, which is really cool, being able to take and tag each independent foot with the information that it needs. Now, we did not use that to its utmost extent. In other words, we were only tracking the foot locks per foot, whereas we could have put individual timers on the foot, we could have put previous world locations, all of that stuff all on each foot in metadata. So, but we didn't quite go that far with it, because there may be some efficiencies as far as like in ControlRig getting the metadata out of each of the individual feet, in the actual node network. So just something to consider, but it's cool that we can do it. Another thing about managing the data is, so we actually went mostly with an implementation of having an array, and that array, then we have a bunch of arrays. We had the foot target array. We had the, let's see, what were all of our arrays? We had our foot bones, we had our effectors, we had our world location, target locations, current locations, our foot offset time. That's a lot of arrays. It's a lot of arrays to keep track of and manage and everything like that. But we did it successfully. One thing that I would potentially look at in the future is using a struct instead. So if you had a struct, and the struct was literally foot cache location, foot target location, current location, offset time, all of the things that were in the arrays where we were having to get at, then what you would do is you'd have an array of that struct. So each foot would have its own bit of information in the struct, and you would just access the thing, and then everything would work from that index. So that is another potential way to look at the data management aspect of this. And then let's see here, debug drawing. That was huge, obviously, even today. It keeps coming up, so just keeping in mind, the big caveat with that is remembering that being able to visualize what's happening, where all of our pieces are, etc. is huge, but also keep in mind that it is easy to be drawing the wrong thing and mislead yourself. Because if you don't have your world space conversions right, or etc., that can be tough. And then that brings us to our last one. I feel like in this series, we legit solidified our understanding, or even pulled back the fog on our understanding of the entire world space, global rig space, and local space of ControlRig and how it all works. So I don't personally feel like, I mean, in general, in rigging, I understand the difference between world space and local space. It's always only ever been two things for me. ControlRig introduces a third one, and there's an overloaded naming in ControlRig that makes it potentially confusing. So global space in ControlRig is not world space. Global space in ControlRig is rig space. It is the global space relative to the rig. Local space is local space. That's good for everybody who's worth that. And then there's a world space. So the understanding of when we use from world to world, etc., where we do our calculations, are we going to do them in world space? Are we going to do them in rig space? And also understanding a bunch of these things, drawing debug lines, for example, you would think works in world space. It doesn't. It works in rig space. Sphere traces also works in rig space. Figuring out what's correct for that stuff, I think we did a lot to solidify our understanding in that whole rig space, world space understanding. So with that, this is the bow on the Octa-bot series. The model is already available for Patreon members, and then we'll obviously do this. There's more that you can do. We also did a bunch, like we're currently using the animation blueprint to trigger our control rig, which causes our character to walk. You know, you'll have to explore on your own, doing things like, you know, how might you integrate a jump into this? Because right now, if we jump, our character's legs will run while they're in the air, for example. So with that, let's open up for any, we got about 10 minutes left. See if we have any general questions for you all. So let me bring this up and see where we're at. So generally speaking, SO and Farley, what I try to do these every week at 11:30 a.m. Pacific Standard Time on Wednesdays. Now, if you're on the other side of the date line, that I don't know if that's still Wednesday, but if you check, I usually put the stream up the day. I try to put it up the weekend before, but lately I've been so busy, I'm getting it up the night before. But if you, I don't know if you have to subscribe to the channel, but I think It's anybody who's actually subscribed to the channel, let me know when I post that there's a new event coming up. Do you get notification? If so, that may be a way to do it. Otherwise, we generally shoot for 11:30 a.m. this time. And keep in mind, I think daylight savings time is coming up in the US at some point. But so we generally start about an hour ago, wherever you happen to live. So, all right. With that, you all, did we have any other questions before we call today a wrap, or are we going to end it early? All right, crickets. Well, if you do have questions, Off the Rails doesn't get notifications. You get a notification when it starts. Oh, that's interesting. Rusty! Oh no, it's the first time you've missed in like forever. Richie, same for you. Okay, well, you missed an amazing blue screen of death. Okay, so it sounds like if I schedule a stream, you may not get notified of that. I'll tell you what, this week I will schedule the stream by Saturday night. And you all, for all of you all that are subscribed, you can let me know if you got notification that there was an upcoming stream. Otherwise, it sounds like you may only get pinged when I actually go live. We'll sort that out and get to it. Okay, so Rusty, Richie, you didn't miss a ton. We just kind of put a bow on our Octa-bot series. You can go back and watch it. All the videos stay available in the live section. Feel free to go back and watch as many as you want. The only reason they wouldn't stay is because if I am completely wrong about something we're doing and somebody calls it out and we realize we made a pretty big error, and I don't want to mislead anybody, so we'll take down a something and or re-record it or put a note on it. So all right, with that, if there aren't any, oh yeah, what I was saying, if there aren't any general questions, we'll call it a wrap today. But fear not, because if you do have questions, there is a Discord. Hop in the Discord, ask questions in there. Everybody's doing a great job of helping each other out, trying to answer questions and so on. And then, as I said, next week, we're going to start our quadruped series. And next week's class is going to be more of a lecture. So less Unreal, all lecture. And we may not even use the whole time. We'll see. All right, y'all. Have an amazing rest of your week, amazing rest of your Wednesday. I will catch you all on the next one. Take it easy.